question first. Here I have mentioned about the motion of a particle in altogether 8-second journey, out of which first 4 second is moving with the constant speed, right? First 4 second it is moving with constant speed, as I have mentioned, that is 4 meter per second, and after that it starts accelerating. First 4 second moving with constant speed of 4 meter per second, then for the next 4 second it is accelerating, means moving under constant acceleration of 1 meter per second square. So altogether it is a journey of how much? 8 second. So tell me the total, tell me about the average velocity as well as average speed. So can you tell me what is the meaning of average velocity of a journey? How do we calculate average velocity? Correct. And average speed? What will be the idea of calculating average velocity and average speed? Total? No. Net total displacement by total time. There will be two different modes of motion. First 4 second is the motion under constant speed, or you can mention it velocity. I am concerning about the motion in one straight line only. So during the first 4 second it is moving with the constant velocity, and then in next 4 second it is accelerating. So that means two different displacements will altogether give you the total displacement in a 8-second journey. So average velocity will be total displacement by total time taken. Okay. Average velocity is equal to total displacement by total time taken, right? So total displacement it will be in two phases. First one is with the constant velocity. If I mark the position as A at t equal to 0 second, from A to B it is traveling. This is the instant of 4 second. So during this first 4 second the body is moving with the constant velocity of 4 meter per second. So I can say this is the displacement in first 4 second, and this S1 can be calculated by using velocity into time, right? So 4 into 4 means it is 16 meter. So in first 4 second the particle travels through 16 meter, and then in next phase it is said that it is accelerating. That does mean from B, that is t equal to 4 second onwards, in next 4 seconds suppose it is reaching somewhere C, marking the position of the particle at C. This is at t equal to 8 second from beginning. So the next phase of journey is B to C, and this is definitely performed under constant acceleration. So I can refer the particle is experiencing an acceleration of 1 meter per second. So during the second phase of motion, that is this S2 is concerned, S2 will be considered to be a journey that begins from B and ends at C. That means 2 for us, the ending point of the discussion is C. So S2 will be calculated using the formula ut plus half at square. Keep it in mind. Whenever a motion is performed under constant acceleration, right, we used to calculate it using S is equal to ut plus half at square. So u means u at B, right? More specifically, the starting position is B. So that's why velocity at b into time of journey plus half into acceleration of the journey into t square. So as we know that the first phase of the motion is maintained with the constant velocity, right? So that's why velocity at b that should be referred as 4 meter per second. So for the accelerated motion, are you getting me or not? For the accelerated motion, that is the second part of the journey, for which b will be the starting point, and that starting point velocity is referred to be u in the formula, right? So that u at b will be taken 4. Next journey time is also 4 plus half into acceleration 1 into t square, that is 4 square. Got it now? So it will be, calculation will reach to 16 plus 16 by 2, that is 8. So this is second phase is 24 meter. Are you getting me or not? So the particle is altogether traveling 16 plus 24. In first 4 seconds it is just traveling through 16 meter under constant velocity, and then in the second phase of the motion in continuation, that is t equal to 4 second to t equal to 8 second, this journey is performed where the starting velocity will be the velocity at b, which was 4 only, and after that velocity increases at every instant, right? So total displacement, so therefore total displacement will be s1 plus s2. So we can write down it is 16 plus 24, so that is 40 meter. 40 meter is the total displacement for this particle in a journey of 8 seconds. So therefore, average velocity, that average velocity will be total displacement by total time taken. So it will be 5 meter per second. Got it now? How to calculate average velocity of any journey? Okay. Whatever be the different phases given in an overall journey, you need to calculate the total displacement in a given time taken during which average velocity has been asked. So that total displacement divided by the total time taken will be the average velocity. Now after this, the another part of the calculation, that is relating to average speed. So you always need to calculate average speed. See, for average speed, it will be the total distance traveled by total time taken, that is the total time of journey. So since in this particular case, we can see the particle is continuously moving forward. There is no backward motion involved in 8 seconds, right? So I will write down since in 8 seconds of journey, particle is only moving forward, means displacement is equal to distance traveled. Okay. In 8 seconds of journey, here in this case, according to the situation, according to the calculation, what we have seen that the particle is continuously moving forward. It is not coming back for any part of the in any small time of out of this 8 seconds of journey, right? So as because it is continuously moving forward, so we can say the displacement is equal to distance traveled. So that's why average speed calculation will also come same. The displacement and distance will be same, both 40 meter divided by the journey time taken 8, so it is again 5 meter per second. So here in this case, average velocity and average speed both are equal in value. Is that clear?